we're going to start on it at least. Let me see. You go to home. Okay. You can follow along if you want to, but of course you don't need to. I'm going to take it in the quiz so that you can see maybe how you're supposed to do it. Here's the data set, and it asks you to go away, and you click yes. It will also ask you that in the exam, by the way. Then you just click OK because SPSS should be enabled, so that should be okay. There are a few things in here, and let's read the description. That's the wrong one. Here. So the data set contains information on N is 2584 generated CVs of students from the University of Pennsylvania. These CVs were sent to employers who rated them from 1 to 10 on how interested they were in hiring them, where higher numbers indicate they were more interested. You are interested in studying what traits employers value in CVs and whether they are discriminating by race or gender in their ratings. So we get a few variables, and we get rating, 1 to 10, GPA, 0 to 4, higher is better, white, dummy variable, 1 if white, 0 if non-white, female, 1 if female, 0 if male. Tech skills, dummy variable for if the student has computer programming skills. We have unpaid internship, dummy if the student ever did an unpaid internship, top internship if it was a prestigious internship at a top firm, and second internship if he or she did a second internship. All right, so that is our data. I have opened it already here. You can go with me or just watch. The first questions usually are the easy ones, but not always. I have to admit, in the actual exam that we took this year, I think the first questions were the most difficult. You had to create a model yourself, which we never did before. So yeah, it wasn't a difficult model, but it was definitely a tricky question in that sense. So we want to know the sample correlation between rating and GPA. So we go to our output, we go to analyze, and you go to correlate. You go to bivariate, and you put in rating and your GPA, if I am correct. Rating and GPA. And you press OK. If you had wanted the covariance as well, you should have taken covariance under options, if I'm right. But now you don't. And like I explained, you get a few numbers. You get Pearson correlation, which is our correlation. And you use 0.242 because, of course, the correlation with itself, rating with rating, is always 1. So you take this one and you type in the answer. And actually, it's just as easy as that. You already have 1 point, right? And yeah, you just need to know how to do it, and you should be fine. Let X be the sample correlation between rating and GPA from the previous question. All right, so what was it? It was 0.242. Correlation, okay. Choose the answer which best describes the interpretation of X. Then there are 4 answers. We're going to go over all of them and we discuss which is right and why the others are wrong. So it says, if rating increases by 1, then GPA will on average increase by X, holding all else equal. It's wrong. Why is it wrong? And I have to say this, I think this is quite a difficult question because you have to know very well what your correlation is and how it compares to other measures such as your regression. So if rating increases by 1, then GPA will on average increase by X is not true. Why is it not true? Because your correlation doesn't say anything with units. It could be that if rating increases by 1, that GPA goes up with 9, for example, or that it goes up with 6. But your correlation is always between -1 and 1. So the first one cannot be correct because the first one is about a regression analysis and the coefficients. It's not about correlation. And then second, let X be the sample correlation between rating and GPA from the previous question. Oh, that's incorrect. That's like a little mistake in the question. Okay, so that's actually the question itself, not the answer. So we can stripe that off as well, which I hope won't happen in the test. Then the third one, if GPA increases by 1, then rating will on average increase by X, which is also wrong. And why is it wrong? Because this actually concludes the coefficients and not the correlation. It's actually the same as the first one, just GPA and average rating mixed. But the thing is, like I said, if GPA increases by 1, it might happen that the average rating can increase by 10 or something. And correlation is about numbers that are between -1 and 1. It's about how strongly they are related, not by how much if one increases, the other one increases as well. Remember, we said 3 things about correlation which should always be included: the strength, the relationship, the kind of relationship, so linearity, the strength, which is weak, positive, or medium, and the direction, which is negative or positive. And that fits the fourth answer. X is positive but small, so there is a weak, positive, linear. Weak is the strength, positive is the direction, and linear is the kind relationship between rating and GPA. And that is what correlation means. So it must be this answer. Okay, choose the correct way to write down the basic assumption of the regression model with Y is rating as the dependent variable and the following variables as independent variables. So we have 1, 2, 3, 4, 5 other variables. Firstly, how is a model usually constructed? We always have a B0. Do they all include a B0? Yeah, they do. Do they all include the five variables? Yes, they do as well. So they don't differ on that. What do they differ on? They differ on the given x's, and they differ on these, the error terms. Why is this one wrong? This one, the third one, is wrong because it says the expected value of y given the x's is this. But the expected value of y given these has an error term of 0. Because that's the linearity assumption. So it can't be the third one. And it also can't be this one, because this is the expected value of y given that you have some x's. You always need the given x's, and that's only included here. But I already said that this one is wrong, so it must be this one. And why is this one wrong? Well, it doesn't include the given the x's, and it includes the error term, which, of course, if you have the expected value of y, should be 0. So it can't be this one, it can't be this one, it can't be this one, it has to be this one. And that's also how you would do those questions. Might you really just look at the differences, and maybe you don't know all the characteristics that it should have, but at least you can compare them to each other. And if you know that it can't be this, then you always have some other choices. And if you really don't know, always guess. But I think this is a question you could easily answer if you have learned well. Otherwise, then this would probably be like Akvardal or something. It would be bullshit, yeah. definitely. Okay, we go to question 4. Estimate the regression model described in the previous question. So here you see you don't have to come up with the model. So that's probably the easiest. And usually they also give the model again, which is also nice. You have rating as the dependent variable, and the other one says the independent variables. Okay, so we want GPA, technical skills, unpaid internship, top internship, and second internship as the independent variables. So you go to your model, you go to analyze and regression and linear. So you want rating as your dependent, and we had GPA, tech skills, unpaid internship, top internship, and second internship as your independent. You put them in and you click on OK. And then you get this model, right? So 1, 2, 3, 4, 5 variables, which is correct. And what is it going to ask? If you estimated it right, the estimated constant should be minus 3.412. We get that? Yeah, we got it as well, so it is correct. And what was the question? The question was, what is the estimated coefficient on second internship? Well, that is actually a very easy question. If you know how to make the model, you should be easily able to answer this question. So it asks on the second internship, at least if you remember, because that is really my problem. I always have to go back like 5 times. Okay, second internship is 0.346. And since it already has 3 dots, 3 things after the dot, you can just get it like this. So 0.346. And that really is your answer. So not all questions are complicated, at least if you know how to make the model, of course, and the steps in SPSS. That's not unimportant. If we go to question 5, oh, by the way, I found this out during my very last test. I've had like 15 tests online or on Canvas now. And I found out that if you tick this one, it sort of remembers it. And if you go up, then you can see this thing. I didn't know, maybe you all know, but then if you find it difficult, then you know which ones you found difficult. But anyway, I'm probably the only one who didn't know. So if you estimated the regression model correctly, the coefficient on unpaid internship should be 0.253. Did we have that? Unpaid internship, yeah, we had that as well. Choose the answer which best describes the interpretation of this estimated coefficient. So if students took an unpaid internship, all else equal, they would increase their probability of getting a job by 25.3%. This one is wrong. And why is it wrong? Because we don't work with percentages. The coefficient doesn't tell us anything about percentages. It's about units. So if this goes up with 1 unit, then the other one goes up with 0.253 units. That could be, in fact, that of course is a percentage of the 1 unit, but it's not the percentage of what like your wage or your rating already is. And that is what it says here, because it says it goes up with 25.3% of what it already is. But that's not true, of course, because it might be 20 and it goes up with 0.253 units. So it becomes like 20.253. But if you take it in percentages, then it would go up with 5 or something. And of course, that's wrong. All else equal, students who take unpaid internships on average. So remember, we had 2 important things to interpret with the coefficient, and that was on average, which is here, and all else equal, right? So these ceteris paribus. So those are included, have a higher rating of 0.253 than those who did not. That's probably true. As I explained, it goes up with 0.253 units. You don't have to include the unit as long as you don't say its percentages, because that's obviously wrong. And why is this then wrong? This one, first do this one. This one is wrong because yes, it says ceteris paribus, but it doesn't say on average. And of course, it's on average because it could be that one student goes up with only 0.1, but another one goes up with 0.3. But on average, it is 0.253. And your line, your regression line, is always about averages. It's not just one person. Okay, so it cannot be this one. It is close. Like, you really need to know the details. That's also why I stressed there are always two important characteristics. Because this seems quite right. This number is right, it says ceteris paribus, the interpretation is right, but it's not enough. And the same is for this one, because the average rating of students who took unpaid internships is 0.253 higher than the average rating of students who did not take unpaid internships, which is correct. But it doesn't say ceteris paribus. It could be that, for example, the age has changed as well, and that due to that, it's in total 0.253 higher. But that's not what we're looking for. That's not the meaning of a coefficient. The meaning of a coefficient is keeping all else constant. So the only one that can be correct is this one. If I'm going too fast or you have any questions, please interrupt. Okay. Which of the following formulas is the estimator of a 1 minus alpha % confidence interval for coefficient 3 in your regression model? Here, this is actually a pretty easy question if you have learned. Okay, so what's the difference? Here they use betas, and here they use b's. Here they use normal alphas and alpha divided by 2, normal alpha, alpha divided by 2. The first thing that you should have immediately noticed, if you know the theory well, is that it can't be the first two. And even though they look all very similar, that's why it's so important to know your formulas exactly, Because the thing is, it can't be a beta. Why can't it be a beta? Because you have an estimator. And an estimator means you want to estimate this one with your formula. So it can't be in your formula because you don't have it, okay? You want to estimate it with your sample coefficient, your sample coefficients. So it has to be one of those. Which one is it? It's not this one. And let me tell you why. The difference is that you don't divide this one by 2 and this one is divided by 2. And why does that really matter? Because we want a confidence interval. So you have to cut off alpha in total, but you have to cut off alpha divided by 2 at both sides. Because you want, like, if your alpha is 0.05, you have a confidence of 95%. And you want thus an interval of 95%. It's like this two-sided testing. So at each side, you cut off 0.025 alpha, or 2.5%. And that's why if you have the interval estimator, you take half of it and you multiply it with it. Yeah, you take the half of it and its degrees of freedom, you multiply it with the standard coefficient error, and you do the coefficient error plus it to get the upper, and you do this one minus it to get the lower bound, and then you get your interval. Had you taken it like this, you only get an interval that is a lot smaller than 95% if your alpha is 0.05, because you cut off 5% at both sides, so you get actually not a 95% confidence interval, but a 90. and that's not what you want. So again, learn your formulas, and this is your answer. Okay, question 7. So here it's important to know the actual formula, but you can also do this in SPSS. What is the lower bound of the 95% confidence interval for the coefficient on unpaid internship? You go to SPSS. We have our model already, so that's very convenient. Go to regression, you go to linear. And then you go to statistics. You want a confidence interval. By default, it's on 95. I think we should have 95 as well. You click on continue. You have your model in place. You click on OK. And all right, we get our model. And we wanted the lower bound of unpaid internship. Lower bound of unpaid internship. That's one here. And here we have our 95% confidence interval for B. So for our coefficient unpaid internship, 0.016. And that literally is just your answer, 16. So you can do it actually fairly quickly if you know what to do. If there are any questions, interrupt me. Okay, interpret the confidence interval from the previous question. Based on your confidence interval, do you conclude that unpaid internships have a significant effect on students' ratings? Answer both questions. Okay, first we give our interval. Interval is, you put it between brackets, so the lower bound of 0.16. And what is our upper bound? Our upper bound is 0.489. 0.489. That is already part of the question. Like I said, there are two interpretations. So first you give the interval, and then secondly, you have to interpret the confidence interval, and you have to say if it's above 0, below 0, etc. So we first start the true population coefficient for which one is it? Unpaid internships is between this, so you can copy it because why not? With 95% confidence. And you say, since this interval is entirely above 0, we also have at least 95% confidence that the true population is above 0, and thus statistically and thus have statistical positive effect on the student. Like this. Yeah, at the 5%. At the 5% level. So you give your interval, you say that it's between it, and then you say it's above 0. So we also have at least 95% confidence, etc. It could be also that it's below 0, and then you'd say we have at least 95% confidence that it's below 0. If it's between, then you cannot conclude whether it's a positive or negative effect. So always take notice of that. So for example, if it had been -2 to 0.489, you would say, since it includes 0, we cannot include that it has a significant effect or that it's different from 0, etc. But I think that makes sense. All right. You want to test if the model is useless or useful. Which tests did we do to test if an entire model is useful? You could do a t-test, or you could do an f-test. And a t-test is, you can test the model usefulness with a t-test, but that's only if you have one variable, because then you, of course, test the coefficient for the variable. And but now we have, how many, 5 variables or something? So you cannot actually use the t-test. So you're going to need the f-test. Okay, what was the format of an f-test? The format of an f-test was testing whether beta 1 up until including beta 5 was 0. Do you include beta 0? No, you don't include beta 0 because it's a constant. And it's if x changes, then beta 0 still stays the same. So it doesn't help to the usefulness of the model, right? Because if the age is 0, if the education is 0, if everything is 0, there might still be a minimum wage, for example, which is beta 0. But it doesn't help to the usefulness of the model because you test the usefulness of your other coefficients. Because I know this might be a bit difficult to understand, because why? I mean, beta 0 matters, right? Yeah, it does matter, but it doesn't change anyway. And because it doesn't change, you don't have to test it. So that's why you don't test it. And it also doesn't need to be 0. And if it is, it doesn't really matter. The model can still be useful if beta 0 is 0. Because if your minimum wage, for example, would be 0, and the rest, like beta 1, for your age or education would be non-zero, then you could still have a useful model. So this one is wrong, because this includes beta 0, and you don't need beta 0. Okay, okay, is this one right? Because I have beta 1 up until including beta 5 is 0. Okay, that's correct. But this is wrong, because it isn't true that each one has to be non-zero. And why not? That's because it can be useful if only one variable is non-zero. If all the other are 0, it's still useful, right? Because there is one non-zero one, but the other ones are non-zero. So it's not true that each one of them needs to be 0. And again, this is literally just a question if you have learned that you could have known. Okay, so this one is false. This one is false as well, because here you have the beta 0, and we didn't include that. So the true one is this one, second one. All right. What is the formula for your test statistic? Use the formula editor and use n for the number of observations and k for the number of regressors. So which did we use? We used the f-test. So here, if you click on insert, you can do an equation. Let's go down a bit, and here it is. So you use the f-test, and what was again the f-test? The f-test was SSR divided by k. You have to divide this by SSE divided by n minus k minus 1. If I'm correct, this is the right formula. And you can just literally throw in like this, okay? You don't need to fill in anything. You just need to know the formula for one entire point. That's like 0.3 of your grade. And if you don't know the formula, you won't be able to do probably a next question or something. So that's why it's so crucial to know these formulas. To be honest, I'm not sure if I'm entirely correct. I didn't learn them, like this test is a few months ago for me. So I think it is, yeah, this is your F. This is R divided by K over SSE. But you guys really, really need to know those. I mean, for me, it's so long ago and I didn't really learn for this anymore. So, and I still know it. So you guys definitely easily can learn it. It's only a few formulas. And yeah. What is the value of your test statistic in your sample? Well, the F-test, as we said, you can just find it here. Like, this is literally your answer. It's just in a test, you don't need to do anything else. So you can calculate it yourself, of course, if you know the formula, but why go the difficult way if you can do it easy, right? So it's 55.008. And what is the critical value of the test? So unfortunately, you cannot calculate that from SPSS, or you cannot just read it from SPSS. So you will have to calculate it yourself. And how do we do it? You go to Excel. You type isf dot, and do we choose dist or do we choose inf? We choose inf, because the dist is always distribution for the p-value, and the inf is for your critical value. The probability, how much was it? We need to look that up. Where is it? Critical value. I think it's still about unpaid internships, right? Yeah. Can't find the critical value. But I suppose it has to be 95% confident, but it's not. They don't state it clearly. In the test, of course, it will be, but yeah, they don't really hear. So, okay, we will take 95 because that's usually, in the test it will be stated more clearly, but now we will take just 95. So the probability is 0.95. It's always an upper tilt test. And then you have 2 degrees of freedom. You can read those from SPSS. So the first one is 5. So that was K. Remember, the first degrees of freedom is K. And the second one, oh, sorry, that should be 5. And the second one always is N minus K minus 1. If you go to SPSS, then it's this one. So that's 2578. 2578. And this is your critical value. Yeah, it can be right. You copy it, Control copy. And you just put it in, round it off. I think Canvas will do it as well, but yeah, I think we're able to do it ourselves, right? Okay, and now this is the answer that we found. And you're going to have to answer a question based on it, based on the value of your test statistic and your critical value from the previous question. you want to make a conclusion from a test. And you have to also, sorry, you have to tick the one that best describes your answer. Okay, remember that, shall we just go over quickly when to reject it and when not, and then you can easily choose the answer. So when do we reject? We reject if the value, so the t statistic or the f statistic, is bigger than our critical value, right? Is it? Then we reject it, and then our model is useful, because we reject H0, which suggested that all the coefficients are 0, and then it would be useless, of course. So if we reject H0, then we conclude that at least one of them is non-zero, and then we conclude that it's useful. So this one is wrong, because if the value is bigger than the critical value, we reject it. So this one is wrong. We don't fill. This one is again wrong, because it says the same as this one. Then the value, if the value is more than the critical value, we reject it. Yeah, that's true. And if the value is smaller than the critical value, we fail to reject it. That's also true. Is this true? If we reject it, is the model then useful? Yeah, that's true. Because if we reject H0, that means that at least one of the coefficients is more than 0, and thus it has effect. Thus the model is useful. And this one is right. And this is wrong, because here it says then the model is useless. So by just comparing them and looking at the parts, you can find out which is correct. What is the coefficient of determination of the model? Let's see. The coefficient of determination, what was that again? That was just our r squared. And our r squared is 0.096. So again, it's just reading from your graph. 0.096. And then question 15, choose the answer that best describes the interpretation. Okay. The first answer is the model explains COD. So that's the coefficient of determination, percent of the variation in the data on our independent variables, and then COD percent on our dependent variable, COD percent on our predicted value. And here it's 100 times COD percent and that stuff. So on which it differs, it's about the 100 times COD, and it's about predicted value, dependent variable, or independent variables. Which is correct? Is the COD percentage correct, or the 100? The 100 is correct. Why is that correct? Because remember that our coefficient of determination is a number below 1, and it gives the percentage. But if it can only be 1 at its biggest. So if it would be this, then it could be 1% at the biggest. Well, that's obviously weird if you want to explain, actually want to explain 100%, which you never manage to, but you want to. So this is wrong. Those three are wrong. Then we have 3 answers left. So 100 times COD. Our COD was 0.096, which means that it explains 9.6 of the variation. So 9.6 of the variation is that in our independent variables, our dependent variables, or our predicted value? Well, I understand that you could think that both of these are correct. It's either one of those, indeed. Why is this one wrong, the predicted value? It is wrong because the model explains the variation of the data of our actual variables and not of the predicted value. So this is really, we never talked about this. So it's either one of those. Why would it explain? Our model doesn't explain a predicted value, right? Because we predict a value, it doesn't explain the predicted value. Okay, so then it's either this or this one. The model explains 100% of the variation in the data on our independent variables. And really, it's one of those. It's a bit difficult to explain. I had this one wrong myself. But it's this one. And why it's this one? Because 90. I must say it's formulated a bit weird, I think. But what they mean is that 100%, 100 times 0.096 in this case, so 9.6% of the variation of the data of our dependent variable is explained. I must say it really is formulated quite difficult. If you look in the answers, let me quickly, because at least I think it was this answer, but yeah, that was the only question I've never really understood very well. So that's my bad, and now it becomes your bad, but. So question 15, no. Of course here. On our dependent variable. So 100, we had that correct, of course, and it explains it on our dependent variable. I think it's formulated rather weird of the data on our dependent variable. But what it just means is that, 9.6% of the variation of the data of our dependent variable is explained. I think it would be more clear if they had said off than on, but I mean it's just a way of formulating things, how things are. So I hope you understand that. I think we're going a bit over time already, so I think it's not a very good idea to finish it. You probably have other things to do as well. I stopped sharing. Sorry, that was accidentally. But if you have any questions about what we discussed, you can ask them now. If I went too fast at anything, with anything, please unmute. And if anyone wants, by the way, could someone please comment on how I did? Because I don't know, because I can't see you. And I really don't know. Maybe you hated what I've taught you, and I'll never know.